Greetings, everyone. Thank you for taking your time to join us today. We are excited to have you with us for today's webinar, Turn Trusted Data into AI Ready Data. I'm Ritvie Sarangi, Growth Marketing Manager here at Datagaps, and I'll be your host for today's session. AI has become the focus of almost every business conversation today. Organizations are investing heavily in AI, automation, and large language models to drive innovation and make smarter decisions. But here's the question we'd like to explore today. Can AI truly be trusted if the data behind it isn't? Every day data changes, pipeline breaks, schema evolve, business rule shifts. Without continuous validation, even trusted data can become unreliable, leading to inaccurate insights, compliance risk, and AI outputs you simply can't depend on. That's why today's discussion is so important. Over the next 45 to 60 minutes, we'll explore how organization can build a strong data foundation through continuous validation, automated testing, and proactive data quality monitoring, ensuring that the data powering the AI remains accurate, reliable, and business ready. Before we get started, a couple of housekeeping comments. First, we have muted all the mics to avoid unintended distraction. Second, we have a couple of questions coming up from time to time for you to answer. And if you have any queries, please type it in our Q&A section. We'll answer them all at the end of the session. On the panel today, we have Anand Rao, our VP of Marketing, and Subhanshu Dixit, Senior Solution Architect here at Datagaps. With this, I'll hand it over to Anand. The stage is all yours.
Thank you, Ritvi. And hello, everyone. Thank you for joining us today. Today, we are covering a shift in enterprise data, moving from clean data to AI-ready data. Most organizations trust their data quality, but Gartner finds that only about 40% of AI prototypes reach production, usually due to data and infrastructure debt, not algorithms. So over the next 45 minutes, I'll cover what AI-ready data means, the structural forces blocking AI from scaling, how Datagaps addresses them, along with a demo that Subhanshu is going to lead, and a readiness framework that you can use. So let's get started. So here's how we'll spend our time. The session has 4 parts. First, the AI Readiness Imperative, risk indicators, structural challenges, and why validation matters when data feeds AI models. Second, Datagaps capabilities for organizations to reduce their risk, rebuild the trust in their data that feeds AI. Third, we'll do a live demo showing the platform catching failures before they reach a model or decision maker. And finally, a practical checklist, key conclusions, and potential next steps. So please feel free to send in your questions as the presentation progresses. So in the first section, we'll cover why AI readiness is an imperative and not optional. So moving data or standing up models without a disciplined validation creates reporting errors, broken workflows, and business risk that surfaces after you go live, when it's most expensive to fix. And AI multiplies that risk, since models consume data automatically and act on it without human sanity checks. So I'll cover this shift from can AI help us to why isn't our AI scaling? What separates clean data from ready data, and the 8 conditions AI ready data must satisfy, and the big 3 structural forces: fragmentation, scalability collapse, and semantic ambiguity, damaging AI initiatives. So ask yourself, which of these do you recognize in your own environment? So on the left side is the old world. Clean data, built for humans. It moves in batches, looks like a readable table, and gets checked every quarter or so. Small errors are fine since the human notices odd values and asks follow up questions. On the right is AI ready data built for machines. It moves in seconds, must be usable by software, not just readable by people. Information about the data travels with it, not elsewhere. Rules protecting sensitive data exist, and the tracking the data history runs automatically in real time. So meanings stay consistent across systems, and problems get caught as data flows, not after the fact. This isn't a small upgrade, it's a different setup, different tools, and a different way of working. It's the gap between a model that works in your test notebook and one that works in the real world. So if a stakeholder asks why more investment is needed, show them this. The real question isn't whether the data is clean, but whether it's ready for systems that cannot ask follow-up questions. So here are the 8 things AI-ready data must have. First, it should be accurate. The values reflect reality, follow business rules. It should be complete. The models get the full picture. They need to learn to use useful patterns. Consistent. A customer, an account, or a metric means the same thing in every system. Fresh. The data reflects what's happening now, not what happened yesterday. Traceable, you can show where a value came from, how it changed, where it ended up. Governed, sensitive data should be protected before it's used, not when something goes wrong. And observable, problems are caught automatically before they damage the results. And machine usable, the metadata, features, the structure are organized enough for automated systems to use reliably. So now ask yourself, how many of these 8 conditions that you have can you really achieve with manual testing, spreadsheets, and one-off SQL checks? So at a large scale, AI readiness isn't a project you finish once and move on. It's an ongoing discipline, ongoing checks, automated monitoring, and governance built into your cloud, data, and AI systems. So that difference, the discipline instead of one-time project, is what separates companies that scale AI successfully from those that get stuck. So when we trace the AI failures back to their root cause, 3 problems show up again and again, and they shape the rest of this section. First is data fragmentation. Company data is scattered across databases, files, apps, cloud systems, and different departments. So AI needs a complete picture, but scattered data gives it a partial, incomplete information. That's often why the AI assistants make things up, not because the model is weak, but because it can't find the full picture. Second is the scalability collapse. So manual checks work fine for a few tables, but break down once you have thousands of tables, billions of records, or frequent updates. Handwritten checks become a bottleneck, and whoever wrote them becomes the single point of failure. And third is semantic ambiguity. AI struggles badly with inconsistent meaning. So if a customer means 3 different things across systems and models learn false relationship, so that becomes an issue. So these 3 problems lead directly to real failures: incomplete training data, accuracy that quietly gets worse over time, and private data leaking into these models. So the results show up as broken dashboards, wrong predictions, unreliable assistance, and legal risk. So we'll talk more as how Datagaps solves these problems. So let me briefly dive into each of these problems. So first is data fragmentation. So nearly every customer has it, and you probably relate to it as well. decades of disconnected systems, mainframes, warehouses, apps, BI tools, spreadsheets, APIs. So all these create inconsistent customer IDs and transactions that change shape end to end. Follow these IDs, and the metrics are calculated differently for each tool. And the worst thing for AI, the models trained on one field version but served in another live, and together these make a complete picture impossible, causing AI hallucinations. So we'll talk about how this can be fixed by connecting to 200 plus sources or more, or how many ever you have, and validating the consistency across all of them. The second problem is, a quiet killer. So AI models degrade silently, giving confident wrong answers while everyone assumes things are fine. So the common culprits are the columns changing the type, the missing fields, incomplete joins, reformatted IDs, any kind of time zone shifts, renamed categories. So a human notices a bad dashboard. However, an AI model doesn't. So this drives weeks of bad decisions going unnoticed. So occasional checks aren't enough for systems using data every minute. And we need a quality monitor that fixes these automated checks and has anomaly detection and pipeline testing and continuous quality tracking. Now, the scalability collapse starts with the governance. So we are talking about the second bucket of issues. So the old style approaches can't keep up with the AI. Regulated industries need what's called as defensible AI, so provable records of every data change. So reactive governance, where you have periodic audits or occasional access reviews, works for annual reports, but not for fast moving AI pipelines. So the fix is using governance in motion. Compliance is built into the data flow via dynamic PII masking, fine grained role based access control, and unchangeable lineage tracking. So you add the model cards, the data sheets documenting the model behavior and the data provenance, and you have regulatory ready governance. So, one of the most dangerous AI failures is that the training data doesn't match the live production data. So, this is due to schema changes or inconsistent data preparation steps. And the models look great in testing, then fail silently in production via silent accuracy decay, schema drift, distribution shifts, or any kind of compliance exposure. And the model keeps answering while the accuracy erodes unnoticed, while driving bad decisions for multiple weeks. So, as you see here, Gartner predicts 70% of companies will adopt some kind of data observability tool by 2027. And this is up from 50% in 2025. So there's a lot of movement there, and you need proactive observability that solves this end to end. So the other challenge is that manual data testing cannot keep up with the pace and scale of AI demands. So more sources, more changes, more frequent releases, more need for retraining. And so these four pressures strain every program. So thousands of tables instead of tens, multiple releases every week, multimodal data, and the constant retraining that turns manual checking into a bottleneck, and any kind of script authors into single points of failure. So companies must automate or accept a hard ceiling on AI growth. So you need an automated mechanism that replaces manual testing with fast automated checks that scales to billions of records. So, as you can see here, Gartner predicts that companies will prefer synthetic data over real data for training AI by 2030. Since real data is scarce, it's expensive, it's privacy restricted, or missing those rare cases that you need to test for. So these common approaches all fail. So production data risks HIPAA, GDPR, or CCPA violations, basic masking destroys those relationships between data fields. And if you take small samples, you miss those rare events. And hand built data lacks that realistic nature of production data. So things like healthcare, fraud detection, and predictive maintenance each hit these walls when these edge cases are not detected. So you need an automated tool to fix this with AI generated synthetic data that preserves those relationships, includes those rare cases, and is privacy safe on demand. So the third bucket is semantic ambiguity. And semantic ambiguity has three parts, each hurting AI differently. So first is schema drifts, where fields change type, the length, or the rules upstream, sometimes obvious but often subtle, while pipelines keep running on the now wrong data. The metadata gaps is another bucket where teams don't agree what the fields mean. Confusing meanings, inconsistent terminology causes these AI tools to write queries and give the wrong answers confidently. And fixing these needs both better documentation and machine readable metadata. So Datagaps offers a validator for metadata comparison, and we'll go through that. And we will look at how a tool can generate AI generated descriptions and ground that knowledge. So AI readiness isn't just about raw data. So many AI tools also depend on the business intelligence dashboards, the semantic models, and any kind of approved metrics. So if the business intelligence is wrong, AI is typically wrong too, and the trust collapses in both at once. So there are four risks that I've highlighted here, where you have broken metrics giving confidently wrong AI answers. You have silent upgrade caused drift. And then you have the dashboard versus the AI mismatches. And you have access drift exposing data that tools shouldn't be able to see. So we want something where BI deserves equal priority to AI in readiness planning. And we want to close this gap across any kind of BI tool, Power BI, Tableau, Oracle Analytics, and so on. What data gaps can offer, and this covers why AI readiness matters, and three big problems behind each of the AI failures, and we can look at how the results match what your team is looking at, and tie everything back to those three forces of fragmentation, scalability collapse, and confusing meanings. So here is a big picture, right? Inside the entire suite of data gaps, you have nine key capabilities working together to make your data AI ready. So you have end-to-end validation checks that check data all the way from source to destination across your ingestion, transformation, warehouses, lakehouses, and the reports. And then you have data quality monitoring using the rules, the scores, the dashboards, the alerts, and any anomaly detection across everything you have. Then you have metadata and schema validation that catches the structural changes before they quietly hit and break the pipelines or the models. And then data profiling finds those hidden problems like unusual totals or patterns or lengths and outliers. And then you have AI assisted rule generation, which lets both the business users as well as the technical teams create validation rules and code using OpenAI, Azure OpenAI, or a built-in AI model that runs entirely inside your own environment. And then there's lineage and traceability, giving you a map how the data connects for troubleshooting, understanding the impact, and passing those defensible AI audits. Then you have automation and CI/CD integration, making validation a built-in part of every release instead of an afterthought. And then you have BI validation, extending this coverage into dashboards and reporting layers, and synthetic test data generation that lets you test under realistic conditions without exposing real customer records. So any AI-ready challenge connects to one of or more of these 9 capabilities. So we talked about those 3 structural forces, and we're going to demo these as well. So you can plan your coverage and see it's not that random tour of features. And so under data fragmentation, we'll have schema drift before retraining, tracing data from source to decision, checking the knowledge grounding across multiple systems. And this is all about rebuilding a full picture across scattered systems. So under the scalability collapse, we have large-scale anomaly detection, automated rule enforcement in the release process, self-healing pipelines, and bulk test creation done by AI, all about doing the checking work at a speed and a scale that no manual team can match. And then under the confusing meanings, we have handoffs between the AI systems and checking that training data fairly represents the real world data, proving that data meaning stays consistent and that data sets are fair. So the key point each scenario will, and Subhanshu is going to show that, it shows that the platform catching the fragmentation, scale, or meaning problems before it reaches a model, a dashboard, or the decision maker. So I'll let Subhanshu take it from here and cover those 3 big problems and showcase our capabilities. So Subhanshu, over to you.
Thanks. I'm just waiting to share my screen. So let's get on with the demo. In the next 10 to 15 minutes, I want to show you the preview of the different feature sets what Anand was discussing earlier, and of course, how we approach these problem statements at a lower level. So let's get started with these. So as you can see in this particular slide, there are 2 phases in which we're going to do our validation. It's pre-production versus post-production. In fact, there's a lot that happens in pre-production in terms of standardization of data, making sure the data is adhering to your expected drift, and of course, making sure that synthetic data is being generated appropriately. So while we have a lot of different features that we have covered in past webinars, which ensure that the quality of your data is appropriate, after all, when it comes to AI, it's garbage in, garbage out. We also want to make sure that in today's landscape, we cover other aspects as well. So in this particular scenario, we're assuming that you're working with high quality data. If not, our application can help with that as well. To come to specific pointers for today, the very first one is in terms of synthetic data generation. To give you a quick preview of what that looks like within our product, well, define connections to the corresponding data sources from where you would like to pull these synthetic data sets. As you can see, our application works with a good chunk of different databases and file types. Remember, if you don't see something in this particular screen, we have CData connectors, generic connections, and API connections for that. Then, once the application end user has defined a data model for us, right here, the application automatically picks up the relations, primary key and foreign key relations from these systems in this way. Then, with some sample data, the application then creates synthetic data for the end user itself. These are completely configurable. You can define your very own formulas, your very own big data sets, or a specific line in between. So you have a lot of different options right there. But in most scenarios, all you have to do is just let the application auto recommend the systems and let the algorithm take care of this. Because in the back end, we have a generative AI system built to understand what these data sets are, the relations, their descriptions, and other aspects, and then create synthetic data in accordance. So that is the very first pointer that we would like to get in right there. The actual generation of the data is as simple as well scheduling it or making part of your pipeline, where you decide where exactly this synthetic data is going to be put in, and then you can generate n number of records from this scenario. So let's add a few zeros, and then just save them in a corresponding location based on your use case. That is synthetic data generation. And as discussed, our model takes into account the specific relationships, the statistical anomalies seen within the data, as well as the correlations seen within the data while creating the synthetic version. That's part A. Let's discuss part 2, CI/CD validation gate. This once again goes in line with data quality validation itself. We want to ensure that the data sets we are dealing with adhere to our expected logic. If they don't, we want the release blocked. So to this end, I've given a couple of aspects. So this is a slide that we've discussed in previous webinars as well, which illustrates how our application can automatically integrate itself with your CI/CD pipeline as well as your version control systems. In this example, new requirements or new data sets come into play. And while the model is being updated in the feature branch, where we're ensuring that this new column or new feature set is being kind of accumulated to the entire system, we make sure that it's adhering to its expected business logic in that particular feature. But before we move it to the QA branch, we ensure that in the QA branch itself, the existing test cases still function. It's very simple. We want to make sure that any new additions don't really break anything that was working previously. And this can go through multiple steps. From an actual execution, I'll quickly showcase what this looks like. It's as simple, as defining the CI process. So what you're looking at is an example where we're using GitHub Actions, where when we push something into the main branch, the application first triggers the entire validation pipeline. And in subsequent steps, using the output of this corresponding pipeline, we can call out if a particular build has to be put into failure state and you have to revoke a particular build. So you have a lot of options from that perspective as well. Let's go to the next particular use case. Yeah, the next one is in terms of schema drift detection. So it's pretty straightforward. If you're working with a particular set of data sets where you are using this as part of your pipeline or as part of your training, if there are any changes in the overall, say, profile of the data, or if there are actual metadata changes like a column being added, a data type being altered, or anything of that front, that is something that the application inherently captures. This is something that's done in an automated fashion. When you define your data sources, the application inherently builds up catalogs of the system. Within catalogs, we keep track of all the data sets and their metadata structures, as you can see right here. And this helps us keep track of schema drift. So here we know which tables are affected by which particular change. And most importantly, its consequence, the impact analysis. So as you can see in this example, the application tells us specifically what are the particular data sets and the tables which were affected thanks to the corresponding schema change. The impact analysis goes a bit deeper. The application also has lineage systems that tell you exactly down the line what are the data sets which are affected. And in fact, we can go at this at a column level to tell you exactly the impact of one particular column change across multiple, say, layers, leading all the way to the BI layer. So that is what we wanted to discuss in terms of schema drift. The next 2 pointers, BI AI metric mismatch as well as metadata plus RAG grounding, are really helpful in understanding the overall output of a BI tool itself. Very intrinsic to how you might use generative AI in an existing system. So let's set the stage before we get into the depth of it. This is a problem statement that a few clients have reached out to us asking for customized solutions. So it's a very real problem where if there is a particular AI tool that comes into play, this can be something like Cortex, this can be like Datagaps AI, something specific like that. A question does come up when we ask a generative AI system, hey, what is the average number of sales that we saw for a particular month? And the AI system gives a query. There's a question on who is validating that corresponding query. So this is a pretty big question, and pointers 4 and 5 kind of get into that specification. So let's discuss pointer 5 and 4 in the product itself. When we create our application, and within our application, when we create our validation systems, we make it a point to ensure that we can generate RAG. So what exactly is RAG here? Well, firstly, we start with the logical grouping of tables. This can be grouped up based on layers. This can be grouped up based on accounts in terms of dimensions, facts. We have a lot of different options, and it's as simple as these 3 clicks. And what happens at this point, similar to synthetic data generation, is that the application first picks up the relations in an automated manner. Then, using sample data, it's going to generate descriptions of every column and every table. Now, if there are places where it's already existing in terms of Unity catalog, that is better. But from a governance perspective, it's very important that we cross-reference that the data set indeed does what it's expected to do. For example, a governance tool can simply say that a metric has to be between 150 and 250. It could be random numbers like that. But in the actual data, we see that the metrics are between, say, 0 and 50. So the values are quite distinct. And so there is a distinction between what a governance system might pick up and what descriptions that the application generates. And we believe this would be much more accurate for the very next step, which is grounding the RAG and grounding the context. So in this example, if I look at a particular column, I can specifically understand what is the specific column referring to, what are the values within it, and so on and so forth. And this is something that's true for the AI agent as well, because as you can imagine, we don't want AI agents to hallucinate. That is why we provide appropriate context in the form of this particular RAG. Now let's use this in practice. Let's use it against an AI response. So this is the test case that we were seeing earlier. It was the diagram that Anand was discussing earlier, except in a very different manner, where we're doing 2 or 3 things together. So let's discuss what exactly is happening in this test case. The very first thing that you'll see is that we have a BI report in question. So this is a Power BI report, Tableau, OBIE, multiple BI tools are supported, and it works the same across all of them. But the key gist here is that we have these numbers present from our BI structure, which is again true and tested across multiple years since BI was introduced back, say, in the early 90s or the 2000s. Apart from this, we have a semantic model or your golden layer, which holds golden record. This is in its raw format. Again, the query is present right here, and I'll get to this query shortly. But the key aspect is this represents semantic model. And before we do any important check, it's very important for us to ensure that these two are in sync. Because in the subsequent example, what we're actually going to validate, AI responses against the semantic layer and AI responses against the BI layer, it is a very important check for us to ensure that the the BI reports and the golden model itself match. And this is a very popular use case that we see throughout multiple clients. It's called report to data compare. And it basically ensures that the numbers in your reports match the numbers in your warehouse. And while all of this is pretty straightforward, the real crux comes in when we want to fetch AI responses. So there are multiple ways to associate this. Like in this example, I've given the input that I give to my generative AI system. And this is basically an integration layer that connects to that corresponding AI and fetches the information back. So it's basically what prompt your end user puts in. So in this example, I will basically ask the AI system, I want to see the number of compliance and non-compliant FICA IDs. That's the problem statement that we're dealing with. And the application runs the execution and creates these numbers as is. So we have these numbers. Let's actually do the actual validation, which is making sure that the numbers created by the AI response are in fact comparable against both the semantic model as well as the BI report. So let's see if this is the case. Well, that's not the case. When we compare the numbers against the actual BI tool, we see there are some issues. And yes, the numbers don't really match. Now, one could make an argument that the BI report might not be updated to scale, which is perfectly fine. That's the main reason we also compare the system against the semantic model. This is where we actually bring up the values here. And if I open up this AI summary section, this is exactly what I wanted to see. The same prompt is put right here. And so when we execute this particular test case, we basically parameterize that corresponding AI input, the prompt that we're going to put in, and we make sure that the response matches the BI tool as well as the semantic layer underneath. And before we do all of that, we run a quick sanity check to ensure that the BI reports and databases match as well. So that is our pointer in terms of the BI AI mismatch, as well as in terms of metadata and RAG grounding. The last one is in terms of observability and alerts. So quickly finishing that, the last one is basically ensuring that if there is a drift in the data, if your application if the data sets that you're dealing with are no longer working as expected. So a simple example here would be that we live in some turmoil times in terms of the economic scales. So if you're training your data based on say the last 5 years of say trade and other aspects, that will be pretty good. But once you notice that in the current scenario, these particular data sets and variance is nothing like we have seen before, the machine learning model as well as the AI model fails to actually grasp that into account. There are multiple ways for us to capture this in a very simplistic form. We can look at your BI layer itself, or we can look at the input data, fetch these numbers that you see, say, in your corresponding line chart. More importantly, fetch these numbers at a categorical level, because when we are talking about catching drift, we need to ensure that if there is a drift for a particular sub feature or for a particular partition, we capture that as well. So in this example, you see we have express air and regular air, and different algorithms have been run for both of them. We see express air is facing just a bit of turmoil and the anomalies have been noted. So you can obviously remove them from your data sets. You can proceed accordingly. And in the subsequent step, we see that regular air is much more volatile in nature. And so the application calls out on all anomalies in this particular scenario as well. So those were a few set of examples that the application brings in. Do note that there's a lot more that the application offers, as you can see with this example, where we can do ingestion validation, analysis, cleansing, validation of data, making sure we capture output analysis, also keeping track of data drift, and of course, validation of data in terms of its everyday use, in terms of validation, standardization, and of course, output validation. A lot of different aspects. And if there are any questions, you know where to find us. You can always reach out to us directly. With that, I would like to hand the slides back to Anand. So let me stop sharing right here because we're done with the demo part. Back to you, Anand.
Yeah, thank you, Subhanshu. So let me share my screen. Right. So a great demo from Subhanshu over here. So we have covered why AI readiness matters, the problems working against you, how Datagaps solves them, and a live demo. So now I'll give you three things: the business benefits of AI-ready data, what operationalizing trust really means, and the next steps to get started with Datagaps, including a free trial that you can experience. So let's connect all this to real business results, because none of it matters unless it creates value. So here are 6 benefits that I could think of. Faster AI deployment. So automated checking speeds up the migration, the modernization, and getting those AI models ready. And the 45 to 60% cut in migration testing time that you're going to be seeing. We showed this with earlier, launches and earlier returns. We have seen this in our other customers. The second is higher model reliability, and models trained on complete, consistent, well-governed data perform reliably in production, less drift, fewer retrainings of those models, less firefighting. And then you have lower operational risk. So the rule enforcement, the lineage, the governance tools, and monitoring cut any kind of financial, legal, and reputation risk. And then your improved business trust. So AI adoption depends on trust, and checking data from source to dashboard builds confidence in both reports and AI. And that confidence, not the technology itself, is usually what determines whether a company can scale that AI. And then better compliance, secure setups, quality rules, lineage, audit readiness, and privacy-safe synthetic data that we showed you directly answer what any kind of auditor or regulator asks about. And the big thing is less manual work. So we have seen in our other customers, we have case studies for them showing how they lowered QA costs, less testing time, and better use of their resources, freeing teams for all the higher value work and other projects like the next AI use case. So when you bring this to your leaders, lead with these results. These tools are just how you get there. So let me close. So success starts with the data readiness. Companies don't become AI ready just by buying a model or moving data to the cloud. Those are steps, not the results. So they become AI ready by building real trust in their data. So the three ideas that I've listed here matter: trusted data that's complete and accurate, continuous checks, not just quarterly audits, and production grade quality, fresh and well governed enough to support AI long term. And Datagaps brings these tools together to deliver all three. And I leave you with one question: if your data were checked today, would it be a model that is seen as a valuable asset or a risk? So, with that, thanks for joining today, and now I'll open it up for Q&A.
Thanks, Anand and Subhanshu, for very insightful session and for showing us a practical walkthrough as well. I hope everyone found today's session helpful and came with a better understanding of why trusted data is the foundation of successful AI initiative. We already have received some great questions through chat. We'll try to answer as many as we can in the time we have. So, Anand, let's start with our first question. The webinar mentioned training serving skew. How do you catch differences between the data a model was trained on and the data it sees in the production?
Right. Yeah, the pre-production and the production kind of scenario, and Subhanshu touched on it a little bit. And I said, as I said, the first cause is structural. The serving pipeline, that's the production pipeline, may compute a feature differently than the training pipeline did, or an upstream schema changed after training. So when these things happen, there are deterministic efforts that are caught with reconciliation and schema drift detection, comparing the features produced by both the training path and the serving path for the same entities, and continuously monitoring the structures feeding the inference pipeline. Beyond the structural, there's also the statistical, right? The data could have drifted, and this drift and outliers are now getting monitored using some kind of statistical profiling of the live feature streams, with alerts when the distribution go beyond the thresholds. So these two are two big buckets where you can compare your training pipeline with the serving pipeline.
Got it. Thank you so much, Anand. I'll take one more question for that. Most of the webinar focus on structured data. How does AI readiness change when the AI system is RAG-based assistant or an LLM working with documents and unstructured content?
Right. Yeah. I mean, when we think about the unstructured content, it all comes down to the context and meaning surrounding that unstructured content. So the metadata quality becomes a data quality problem. So if tables, columns, and business terms are poorly described, the AI assistant will start to guess. So by enriching catalogs with auto-generated business-friendly descriptions, and being the grounding for any kind of AI assistant, is this validated metadata and lineage, rather than the raw schema itself. So we have this kind of unstructured data being governed, and then we have the semantic consistency. So which plays a critical role. So for example, when a person asks an assistant what was the revenue last quarter, the assistant must say must resolve revenue in the same definition the dashboard uses. So validating that AI layer, the semantic layer, and the BI, and ensuring that they agree on the shared metrics is that cross-layer consistency, and that serves any kind of unstructured data to have the same meaning.
Great. Thank you so much, Anand. Now that we are up with our time, like we'll follow up with any remaining questions from the Q&A section by email. Once again, thank you everyone for taking your time and attending this webinar. If you want any of your questions specifically answered, or if you have any requirement which you believe we can help you with, please do reach out to us at contact@datagaps.com, and you can request a free demo by clicking the button that you see on the bottom of your screen. Thank you so much. Have a great rest of the day.
Thank you, everyone.
Thank you.
For further questions, feel free to reach contact@datagaps.com. Scan the below QR code for free demo. Thank you.